Awesome. Thank you, everyone. So today I'm just giving a little bit of repeating what we are going to discuss today. So we are discussing the string unique characters or permutation problems. First one is check if the string has all unique characters. Okay. Second one is permutations. Let's talk about the first one. So if the given string has unique characters, return true. If the given string has duplicates, return false. And one more thing is the given characters are only these are the only valid characters, ASCII characters. What I'm talking about is the given string has only ASCII characters. Okay, only they're represented in red color. So ASCII characters starts from 0 to 127. That means only 128 characters are there. So there is one more algorithm. So here we are talking about n square, right? Order of n square. How can we um, how can we do in order of n? Order of n means only one time. Let's say if I'm giving a string with 1,000 characters, we don't want to do 1,000 into 1,000 times, 1 lakh times, right? We want to just scan only once and find out duplicates. So very good data structure that will help you to look up. What is a data structure that will be helpful for lookup? Anyone can guess?
Hash map,
Hash map, hash table.
hash map.
Those are the very good. So very easy to use them. And how can we use it? That is the is
In
a
C++, we have unordered map,
unordered map.
unordered map.
I
I
see.
mean, STL
I see. I'm not sure how
we
that works.
use.
So, yeah, simple idea here is, let's say in this first algorithm, right? In the order of n square algorithm, one beautiful thing is you are not using any extra space. You are using only two variables, I and j. Just for I is for one loop and j is for the second loop, right? I don't want to show that algorithm, but everyone knows what we are talking, I think, right? So I will loop, first loop, and j starts from I plus 1 all the way to n minus 1. So every time if you start with b, you will start with the rest of the elements j. So I, if I equal to 1, so j will start from 2 to n minus 1. So here you are not using any extra space. But now, algorithm complexity is bad, order of n square. Now let's improve the complexity, the time complexity. Space complexity, yes, yes, space complexity is good. I'm okay to use extra space. What I'm saying is the algorithm little bit I'm changing. So time, can we decrease the time complexity by using extra space? Extra space means you can use any extra data structure. That is the main thing. Extra space, whenever say someone says in entry extra space, what that means is you can use any additional data structures, not only just variables. So what are the different data structures we have? We have string, you can use another arrays, you can use matrix, you can use trees, graphs, hash tables, or linker list. Everything is, all those are data structures. But which data structure will be helpful for our given algorithm? That is the main important thing that we need to figure out. So I think is it Arshad mentioned very good. He says we can use hash tables. So in this example, let's put in hash table. Simple, right? We are checking and putting in a hash table. So let's say hash set is fine. I think hash set means only keys, right? I'm still trying, always confused. Hash table means keys and key and values, whereas hash set is only keys. Is that right, Harshad?
Yes.
Yes, right.
Yeah, hash set. So what we are saying is only keys. Only, we don't need to store any values here. Simple. Okay. Once you find a, put a in the hash table. Once you find, let's say, take this second string. Once you find b, put it in a b. But before putting, you just check is it already there, because hash set or hash table gives a beautiful way to look up with order of one. You no need to scan the hash table again one by one, right? It will just tell you does it exist or not. Similarly, next d will not be there, so this is b, and d is not there, and e is not there. Now when you get this a, right, then immediately we will get true. Is it there? Yes, it's already there. So simply you return false for the algorithm. Of course, let's say string has another 10,000, let's say another 1,000 characters after a, we no need to scan those. But worst case, this is order of n, right? Because here in the given string, scanned all the characters, and when you're scanning the last character, you found the duplicate. But that's the worst case, an order of n, because you scanned all the characters of the string. That's it. You don't scan even extra one another time. It's just maximum worst case. Time complexities and space complexities always about worst case. Okay. So for this string, right? Let's say another string like A, B, B, D. So for A, B, B. So when you're finding B, and then next time when you find the second, third B, you know B is already in the hash table. You no need to scan the D here. So that's a little bit better than the worst case. You are not scanning n elements, you are scanning n minus 1 elements, right? So, but worst case in the given string here, you scanned all the elements. So the time complexity increased by little bit of worsening the space complexity. It's always balancing act when we are writing a very good algorithms, very efficient, or algorithms which needs a lot of performance. We always think about we need to compromise either or those. A little bit of compromising in the space will give you faster results. Okay, so and also we need to think about different aspects as well when we are always talking about space complexity, time complexity. Where are we running? Are we writing a program that will run on a small chip or a small device which doesn't have much memory? Then it's okay to take extra space, extra time to calculate, because you cannot take the memory, you cannot take extra hash tables, or it's always depends on the a lot of additional factors as well. That is why we are learning all these things when we are in a company where you are writing for small devices. Let's assume that you're writing a small algorithm for a small chip that you put it inside the camera. Just assume that camera ram or chip, very small memory, you don't want to take a lot of memory in that situation. Its order of n square is fine, still okay. User will say loading or something, user, you will show something to the user, and user will wait, because you are not have a great flexibility of taking a lot of space. But if you are writing an algorithm for a bigger computer which will run in server, just assume that server has a lot of space, then you are okay to take additional space, additional data structures to make the computation faster, right? So now the computation is faster here. By taking hash table, you are solving the problem very quick, right? So that's the analogy between the time complexity and space complexity. So if you have any questions, ask anytime, no problem. Or if you are okay, understood everything, I just give a thumbs up so that I will get some response. Okay, everyone understood, I will go for further. Okay, so now this hash table functionality we can implement, since here hash table is for, yeah, hash table is for basically for anyone, like anything will work. And what I mean is any type of string which not only ASCII characters, other than ASCII characters, there will be a lot of characters other than these. These are just a very basic standard ASCII character list. So let's assume if the given string is it has all the other extended ASCII characters, or as well, here there is an extended ASCII characters. So in that situation, just using a normal hash table will work. But in this given algorithm, I'm saying only ASCII characters of 0 to 127. In this case, you can use hash table, or you can simply use the integer table as well, just integer array. That's the algorithm here. So I'm going to share the algorithm. I usually put algorithms in online debugger, GDB. Online GDB is a website I placed all of my algorithms. So I will give the link to this algorithm as well. So I can show I have all the algorithms of strings, arrays, everything is here. So every these are the major concepts. So strings, we have all algorithms. I think Tarun, we are preparing Excel sheet also, right, with all the links. Yeah. So strings we have, arrays we have. So I will share the link. To
Yes,
yeah.
if
Yeah, I will. Please join whoever Raghunath and new person Srinivas. Please join the Discord channel. Here is the Discord channel. Ping me on the Discord channel. Here is my ID. I think I can copy. Is it copied? I think it is copied. So
can you? Can you do the text message here? Like,
Yeah, yep.
I already opened the my Discord, so I want to
Sure, sure. Please,
join.
yeah, please text me so that I will add to the one of the groups so that you
Yeah,
will see
sure.
all the links, all the announcements, or everything. Okay. So,
Yeah, sure.
good.
And to open this video, like whatever we are talking in the laptop, how I can do that? Because I want to see in the big screen. I'm just doing now mobile, so I cannot able to view much what you are showing.
Oh, so you joined through mobile,
Yeah,
so you can't see my screen properly. You can. I don't know whether you can see this. Can you zoom it or no?
yeah, I can do Zoom,
Yeah.
but when someone talks or something, it is moving here and there.
Oh, I see. I'm not sure.
Yeah.
I usually log in from laptop. So or maybe try the
Okay.
app. This Gypsy has a nice app as well. So I never tried an
Okay.
app. So maybe app will give you a better flexibility.
Okay. Sure. I do.
Yeah,
Yeah. Thank you.
no problem. So here is the simple algorithm. What I'm saying is since the characters are ASCII characters, so what I'm doing here is okay. So what I'm doing here is character set. I'm taking a bool variables. Okay. So simple thing is since it is restricted to um, to the 128 characters, right? So what I'm saying is I'm taking a bool table boolean table of 128 characters. Okay. So let's say str of 5, str of, let's say, 2, str of 2. What is str of 2 here? D, right? 0, 1, 2. So D, capital D. Okay. So now this boolean variable is like let's say c ch, or checking table. Now checking table ch of D. If I say ch of D, it will automatically convert into the actual value of D. So that means D, what is the value of D? In the ASCII characters, capital D is number hexadecimal 68 or 44 in hexas, or this will directly go to that number. So it will go to the 68. In the 68, let's say this is 68. In the 68 cell, we are going to put as true. What I'm saying is every character has its own number, right? So D is 68, and capital A is 65, capital B is 66. If it is small a, it will be 97. So every character has its own number. So if we can convert the character into number, we can directly go there. Basically, it is simply using an array is enough. No need to use hash table. So we are using an array with a hash table kind of functionality. So we are directly, it's a hash table. You can think of this as a hash function. Hash tables always work with the hash function, right? So this hash function here is ASCII table is a hash table hash function. So if you give a small k, it will give you 107, or if you give 107, it will be represented as k. There is no character in this table with the value 107 except a lowercase k. So there is a hashing function. There is a link between this lowercase a and 107. Similarly, small lowercase a with 97. So it's a unique, right? It's a hash function that was already built into the language, so we can use that. So that's the main logic here. So what I'm taking here is another thing. This is the condition here. I'm sharing the actual algorithm here. So e is unique characters is the function. So we are taking a string, okay, and it will return boolean. Now string dot length, we can use length. Let's assume that we can use length function. If the string dot length is greater than 28, we need to return false because our algorithm cannot work. Because we in the algorithm we are using the ASCII table. We are using this ASCII table mapping. Okay. If you are using any string which is greater than 128, uh, no, why we need to? It could be greater than 128. Oh, yeah, yeah, yeah. Okay. Let me think about it. So if you have more than 128, what happens is um, it won't work. So it definitely, yeah, that's it, right? Basically, let's say you are passing a string with 129 characters, and you are allowed to use these 128 characters, right? Definitely there is a duplicate. Simple, right? You can use only these number of characters, but you are giving something. Your the input is a string with 150 characters, right? You cannot build the same characters using the same characters. You cannot build 150 characters length of string, right? The maximum length is you can use any of these characters with only once. But if you are using at least extra one character, 129th character from the same table, that means there is a duplicate. You no need to run the algorithm, isn't it? You understood the logic here? Give a thumbs up if it,
Yes.
yeah. So that's why it is a false here. Basically, if the length is greater than 28, simply return false. Now coming here, length is not 120. Let's say the string has 10 characters. What we are doing is, even though we have 10 characters, we are completely taking 128 boolean array. 128, this is simple. 128 is not a big memory. It's simple boolean of 128 characters, and we are looping only once. So this is the main thing here. Only order of n. We are using the string, and we are navigating using I as a index from 0 to length minus 1. Okay. So what we are doing is first taking the val. So str of I, an integer. So what this line will does is it will convert the character into the integer number. Since this is most of the languages will work like this. So character str of I is capital A. Let's say in our example the first character is capital A, right? So what happens here is this val, the val variable will be assigned the value 65. Okay. Now what we do is simply check whether the character set, this is a character set, or you can think of this as a hash table. We need to check whether the value is already true. So every language, if you take a boolean array, the default value will be false, right? So if the value is true, so this is true condition, right? If the value is true means already found this character in the string. That means you already set the character as a true. But now let's assume that first time you are running and A is the character and 65 is the value, and definitely it will be false. So it won't return here. Now it will come to this line. Now you are setting that particular character as true. So what happens is after scanning the character A, let's assume this is 64. 64 is here. Then this will become true, right? Next B, 65. This will become true. Next E, A, B, C, D, E. So the E will become true. Similarly, when you find A again, then it's already true, right? That means you already encountered this character. So rest of in the Boolean array, rest of the things are false. But the one you already found as true, that means it's a duplicate. So simply it will return false. So let's assume that you completed the loop successfully. That means you marked all the characters in true. That means for the, let's say for the first algorithm, right? For the first algorithm, what we do, we'll find in this 128 characters in the Boolean array. Let's say this is 64. So you start marking as true, and B as true, A, B, C, D as true, and E as true, and F as true. That's it, done. You never encountered any duplicate. You never encountered or checked visited element which you already set as true, right? You successfully completed the loop. You successfully completed the loop, and you marked every character as true in the table. That means the given string is unique. Every character in the string is unique. That's why we are returning true. So I already put a comment here. We did not find any duplicate after scanning the entire string. So the characters are unique. So it's hardly not even 10 lines of algorithm. So there are multiple ways to solve the problems. There are three ways we explained. First one is order of n square having two loops. Very easy. I really like that answer. If even if the candidate says that answer, It's almost like half impressed with that because you already solved the problem. I really like it. Now let's have the conversation. How can we solve in a faster way? So second one is using any hash table, hash set or hash table. And the third one is using a hash table. Rather than using hash table, we can use a normal Boolean array. There will be a little bit of advantage, but I'm really not sure how much it is. It's almost same, I would say. You can use hash table, you can use Boolean array as well. Okay, so this is the algorithm, but that using Boolean array. So any
I'm seeing first time this type of algorithm
if seeing first time, very
making
good.
a
Yeah.
yeah.
So did you like it or any questions or
How
yeah?
yeah, I like it. I don't know like we can use the boolean array and all the values will be false and we can use it as we require. If any element is repeated, you
Mm-hmm.
can mark as true like that.
Yep. It's very interesting because a lot of many algorithms, very double dimension matrix algorithms, or many other algorithms, we use Boolean arrays. Boolean arrays is really helps to determine whatever we want. I think in dynamic programming also we will use arrays, Boolean arrays, to mark the things. Okay, so it's kind of marker. You're checking and marking that value. Okay, so yeah, so just like that, you can in the real life example, just a register. You're a students, right? If you're in the class and you will have the students, you keep on. Someone says his their name. You look at their attendance. Oh, this guy came. You are not calling one by one. You are everyone is standing up. Student is standing up and saying, "Hey, my number is 24." Okay, let's mark the 24 is present. And another student stands. My number is 40. Okay, let's mark 40. So now someone says, let's say on the back bench that guy want to just make a fun of out of it. He says my number is also 40. Then you found, oh, there is a duplicates here, right? So that's how it is. Just another way of looking at the problem is finding taking each character, converting that in integer, and marking that integer value in the Boolean table. Yeah. So this is algorithm. Let's say what is the time complexity we already discussed. It is order of n. We are scanning only every element only one time. What about space complexity here? Anyone want to say the space complexity?
O of one.
Very good, very good. I really like that. Anyone want to comment about that? Why it is O of one? We are not O of one means it doesn't mean that we are using only one amount of memory, right? So why it is O of one?
Constant because it is constant and it's not changing based on input.
Exactly, that is the answer. So I
Memory
always
size is constant.
exactly always 128 characters. We are taking always 128 constant memory size. Okay, it doesn't matter. You give a string of 100 characters. You string give a string of 1 to 150, not 150. Yeah, even 150 characters, you're not even taking that, right? It will just simply return false. Let's say string of 50 characters, string of 60 characters. If the memory is varying based on the input, then it will be a problem. We need to determine how much it is varying and what will be the space complexity. But if it is not varying, the space is always 128, not 128 really, of course. 128 plus you're taking space for I, you're taking space for val. That's it. Yeah, 128. Let's say every boolean. Let's take, I don't know exactly, one kb, 1 kb, and one integer will take, I think, 4 kbs, right? And this integer will take another 4 kbs. Hardly 128 boolean spaces plus another 8 kb. That's it. So constant. It doesn't matter whatever the input. I always reserve maximum, right? Maximum I reserve this amount of kbs or this amount of mbs. You can think of kbs as well, or mbs, whatever it is. It's a constant. That's why it is constant space algorithm and constant time algorithm as well. So of course it's not constant time, it's order of n. Order of n is also okay because without scanning the input, you can't solve the problem. Okay, so order of n, you are scanning only one time, which is good. Give a thumbs up if it is good or if you understood. Any questions, feel free to ask. I'm repeating many times to make sure everyone understood the algorithm. Cool. I got one thumbs up from someone. Two. Cool. Um, I'm going to go to the next one. So next one is in the simple another simple variation here. Very good. So given two strings, write a method to decide if one is a permutation of other. One is a permutation of other. So um, I'm going to erase this. So one is permutation of other. Let's look at the simple inputs here. So here is the algorithm permutation, right? So here is a permutation of the permutation problem. So A, B, C, D. I can also simply write somewhere here as an example. So let's say A, B, C, D, E, and E, D, B, A, C. So see that it is a permutation of other, right? So the same characters in a different order. That is permutation. This is it returns true because you used A, B, C, right, and D, E. Same characters in a different order. So now let's say another example A, B, D, K, and K, B, C, A. It is which return false because there is an element which is D here. D is not available. D is not available in the second string. At the same time, C is not available in the first string. So the second string is not a permutation of first string. Simply return false. Any questions on the question? Is it clearly understood? So write an algorithm to check the two strings. Awesome. So how can we do this? And assume that this is also same ASCII characters.
We can use the same method. Instead of Boolean array, we can take integer array, and we can store the count of each characters. And
Mhm.
after that, we can loop like two arrays. We'll use one for one string and like another for another string. Like we can compare
Hmm.
like both are having the same count or not. If they are having, then it's a permutation. If it is not, then it's not.
Very good, very good. That you're very good. So you're one thing I did not. I think I understood. So what you're saying is you want to take arrays, two arrays, right? So
Yeah.
let's take this input to support the thing you said. So let's say A A C B. So is it true or false for this?
Hmm.
Is it
It
second
is
string is
false because for A it will be two. Not like correct only because A two characters in it will be true
yeah because
because
you use it
count will be same in the
no,
both the arrays, right?
exactly. So you there are two A's and here also two A's. So one A can match to one A, another A
Yeah.
can match to another A, and C was used one time, B was used one time, E was used one time. So it's a perfectly it is second string is a permutation of first string. No doubt about it. Anyone has any questions? Now last example probably
No,
A B C A E and A B C, let's say D. Okay. So let's assume that let me erase this. So A A A B. True or false? What will be the output?
False.
False. Because there are two reasons. The reason is I want to know the reason. There are two reasons. First reason is Why it is?
Count is different for both.
Yeah,
A count of A.
exactly. So for the A, right?
And
A there
C
are,
is not available.
yeah, there are two A's, right? There are three A's, and also C does not exist, right? So what you're saying is you want to maintain the count, right, Arshad? That's a good algorithm. That's actually the final algorithm. Actually, that's it. So for this input, let's take this last input. So you want to maintain a count. A, how many number of times? A two times, and B one time, C one time, and E one time, right? You want to maintain that. And do you also maintain another table for second one? E one time,
Yeah, so
A
that we
three,
can compare. Yeah.
yeah, A three times, and B one time, right? So now you want to compare these two tables. Here is A.
Or there is one more approach.
Very good, very good. Go ahead, please.
So we can reduce we can like maintain only one table and reduce the number of basically reduce the frequency when we get in another string.
Very good, very good. Beautiful algorithm. That's exactly the final one. Actually, you've arrived at. This is a conversation really helped to derive the final solution. It's a very good conversation because Arshad gave a good idea and you extended that idea. So very good. So what? So everyone understood that Arshad, basically here you created two tables. Okay. Now
Yeah,
now
Suresh.
you need to compare. Hey, A how many times here in here, and B here and B. So you need additional array is there. What Modit was saying is, let's scan the first string, scan all the elements of the first string, and put the counts here. Okay, so it's exactly the way we used a Boolean table. It's since it is ASCII tables in the Boolean, what we did is we just use true false. But here, what we do is we will put the count. Instead of booleans we use the same 128 characters, but a how many times? A 10 two times. How many times? B one time. How many times? Z or K zero times. How many times? F zero times. So initially we will put everything zero and then scan the first string and count, put the count, increment the counts. Now what Modit was saying is, once you are done with first string, in the second string, right, with the second string you can start decrementing that count. Because so this A, you found this A. Okay, so now let's say for the first string, right, A is 2. Okay, now when you scan the second one, E is 1, so E becomes 0. So that means E already matched it. Now whenever you find second A here, A becomes 1. Okay, now whenever you found the second A, the 1 becomes 0. A becomes 0. Now whenever you find third A, there is no matching A. That means A already 0. Now A becomes minus 1, because 0 minus 1. That means you need another A. You need another A in the first string to match with this string. That's what it is. Basically, you found a match. Simply, let's assume that all, just a real time example. I want to give a real time example. First string is number of students. First string is number of students and colors of their shirts. Okay, A means blue, B means red, C means blue, purple, whatever it is. So A means blue. There are two people with blue shirts. We need to find two people with blue shirts in the second string as well, in the second class. Let's assume that second string is another class. You're pairing basically. So you already maintain this table. Okay, blue shirt two people, red shirt one people, purple shirt one people, something like that. Now you are taking the second students from the second class. You're pairing. You found A, first A. Oh, you already have a blue in that. Go and pair with that guy. And you found another blue. Oh, you found there is a two people exist. You know that, right? You have this table. So one pair already found, two becomes one. Now for the second A, there is another pair. You say, oh, there is a blue shirt over there. Go and find that and pair. Now for the third person, it becomes zero. It's all minus one. If you say zero or minus one here, like negative, then you found out, oh, you don't have a match. That means second class is cannot be paired with first class, right? That's simple. You can break the loop. So that's what we are doing here, matching. So whenever the count becomes -1, you simply first decrease it, and then you, if it is -1, that means there is no match, right? So now let's talk about yeah, let's talk about this second example. The second example also false. What happens here is, in the second example, A is 1, B is 1, D is 1, and K is 1. Simple, right? Four characters. You mentioned four. You have the count of all four characters. Now you are scanning the second string K. Okay. Is there any K is 1? Yes, K becomes 0. It's fine. Now B. B, you found a match, becomes 0. Now C. Where is C? C not there. But internally, C also 0. So whenever you take this is a very thing, this is a simple standard thing. Whenever you take a Boolean array, every element marked as false. Whenever you are taking an integer array, every element marked as 0, right? So for C, 0 minus 1 becomes -1, right? Then immediately you simply return false. But that there is no match. Basically, simply you're having a A1, B1, D1, K1, and C0. Rest of the elements is 0, right? So for C, whenever you decrement the value, whatever the value, it could be 5, 5 minus 1, 4. But if it is not 5, it is 0. So 0 minus 1 becomes -1. Whenever it becomes negative, then simply return false. The same logic will work for this and work for this, isn't it? You guys followed, Modit?
Yeah, Suresh. Yeah.
So and everybody like,
And
yeah, go
and
ahead,
there
go ahead.
is like one more, like we can put one condition,
Yeah,
like if the both strings length is equal or not, even before entering into this
very good,
like
very good,
algorithm.
very good. So
So
yeah, that is very simple. Yeah, very good condition, because if the lengths are not same, definitely there is second string is not a permutation of first string. That's a boundary condition, or sometimes we call as base condition. We want to check before you enter into the algorithm, right? So if the lengths are, you definitely know one class has 5 students, another class has 6 students. So there is no match. Definitely there is no match, right? So very good. That's why I did not even mention that case here. That's a very good, but that's a boundary or initial step. So is it clear? Just want to check with Srinivas and Raghunath. Am I going fast or am I going okay? Just your feedback. Is it good? Raghunath says okay. Okay. So yeah. So the basic idea here is maintaining the counts will help to navigate. So what is the advantage of doing this? Advantage is simple, order of n. We always want to solve in order of n space. Okay, so we are scanning only one time. You are scanning only one time for first one and only one time for second one. So of course it's let's say order of n plus n, right? Because it's n in the first one and in the second one, so it's order of 2n, 2n or n. So it's not even 2n, you can think of, yeah. So yeah, and for the first one and for the, so it's definitely order of 2n, right? 2n is the order of 2n means order of n, is it right? The complexity. So you are scanning only once.
Yeah.
Yeah, and fixed table, right? Even the space complexity is also same. You're always taking 128 characters of array, because it's ASCII characters. Okay. So Tarun, is it clear, or should I explain again what we are doing, or should I show the algorithm?
Yes, Suresh, it's clear to me.
Okay, let's go ahead, and it's very simple what we have just discussed. So here is another thing. There is one more, of course, I want to discuss here. So let's assume that we can use sort function. Every language has sort. That's a basic. Even we enter into this. Let's say if anyone uses sort function, very simple. You can sort the elements and compare, right? That's of course that's not the main algorithm that I look from the students or from the candidates. So but you guys already started thinking about the actual algorithm. So very basic. Let's say if you can use sort, what we do is we simply str1 dot sort and str2 dot sort. If you use the sort function, what will happen is everything will be sorted. Then simply you can compare those, right? So is it both are equal or not? Let's say the first one, if you sorted, what will happen? A B C D E, and second one is also becomes A B C D E. So then you can simply compare with both are same or not. So if you sort these items, what will happen? It definitely it won't be equal. So but without using sort, we want to solve the problem, right? That's what we just discussed. So here I just give a simple thing, permutation, S1, S2. So first condition, as Modit mentioned, we need to check the lengths. If the lengths are not equal, return false. There is no way first string is a permutation of second string. So if the lengths are equal, then sort s1 is equal to sort s2, return true, otherwise false. If we are okay to use sort function, you no need to write anything. Everything will be taken care inside the sort function, because it will return a string with a proper elements in the sorted order. So both strings will be sorted. Then what will happen if they are equal, if they are permutation, if one string is a permutation of other, you will get the exact same string, right? Whatever the order. So simply return true, otherwise false. But now, how the sorting will work? So sorting is string is to array, and you need to convert into array and array dot sort, and this is the way of sorting it. So sorted string. Of course, if you want to write your own sort, this is the way you are using array sort. But let's forget about all the sorting. We don't want to use sorting. So assume that given string has only ASCII characters. There is only 128 characters. Simply, as I mentioned, the first one is length comparison and return false if the length is not equal, and the next one is character counts. Previously, this is a character boolean. We took a boolean array. Now we took the integer array. So as he mentioned, what we are doing is character array s1 of I. So what it does here is string 1 of I. We are taking a string 1 of I, and it will automatically convert into integer, and it will increment that count. So ASCII of I. This is s1 dot character at I in Java. So if you are using Java, something like this, s1 dot character at I. So what happens is s1 of character at I. So s1 of y means, let's say for this one, right? This is the character A, and whenever you are using in the integer array, you put A for the integer array, it will automatically convert into the number which is 65. A for capital A, it is 64. So, yeah, 65. So that 65 element will be incremented, right? We are doing plus will increment. Initially it will be 0, will increment. So similarly, if you find another A, it will increment, it will become 2, right? So this is simple single line statement, but it is exactly the same statement that we used here. So similarly here, I just took an integer and then I put the integer value here. You can also put the entire thing. You can put this s of I inside this character set. Basically that will automatically convert into integer value in many of the languages. Okay, so that's what I did. So for the first loop, we are scanning all the elements of s1 and incrementing the counts, and now we are scanning the second string s2 dot length, and what we are doing, decrementing. As I said, first decrement and then see if that value is less than 0. As Modit mentioned, let's say if you have two a's, it will be, for two a's it will be still okay. 2 becomes 1 and 1 becomes 0 is fine. But for the third a, for the so here is example, right? For this third a, what will happen? 0 becomes minus 1, since there is no matching. So whenever you see a negative value, this becomes true if s2 has an extra character that has no matching in s1. It could be extra character or a new character, right? A new character which does not even exist in the string one. It will, this condition will work for both situations. Now, for this one, for a, which is third a, or c, In this second example, there is a C which does not exist in the first one, right? Because C is the C value is 0, 0 becomes -1. So it returns false. If you successfully completed this loop, that means return true. So character count, no negative values and no positive values. So by completing this loop, what will happen is everything will be set to 0 again, right? So for the first example, you take A, B, C, D, E, everything is 1, 1, 1, 1, 1. And when you scan these elements E, D, B, A, C, all those elements become 0, 0, 0, 0, 0. That's it. So you never encountered a minus value and you successfully completed the scanning the string. And you did not even sort. That's the beauty of this. The main advantage of here is you are not using sort. Sort is always a little bit time wise it is more, right? So we used a simple integer array to mark the elements. You did not change the input, right? Is it clear or any questions on this one? Anyone? Tarun or just I want to make sure everybody understood the algorithm.
Clear,
It's
Suresh.
clear, Suresh.
Very good, very good. So Modit, Arshad, anyone? Raghunath, Venkat.
Yeah, it's clear, Suresh. Yeah,
It's a
great.
simple. This is like
It's clear, Suresh.
very good. Yeah, this is definitely a simple question that I would ask in the interviews because this will enable us to more talking and more number of ways to solve the problem. Right? People can say order of n square solution, and I can ask about how can we make it more better. Hash tables. We can discuss about hash tables, how the hash table work, and also we can discuss about these integers, booleans, and integers. It will give a lot of discussion points. This is a very good algorithm where you can have a very good discussion with the candidate. That's why I like this algorithm. Okay, so very simple variation of this algorithm. We can I think we can wind up, but I can give it to you guys is max occurrences. It's a simple like given string, find the character that occurred max times. It's the same kind of thing. We can solve really quick. What I'm saying is for the last one here, what is the max occurrence? That means the character which occurred max, right? So for example, the last one is like B, right? And let's say there is one more B here. Okay, then what is the answer? I want to get the answer A, because A is the one which occurred more number of times. A occurred 3 times, B occurred 2 times. The answer should be A. So how can we solve? The same thing. Input is always ASCII characters. How are we going to solve this?
We can scan through the complete string
Mhm.
one by one and
Mhm.
keep it in each letter and its occurrence number of occurrences count into
Yeah,
the value.
yeah.
Uh, yeah, that's it. I think
Then what you done? Then
whichever.
how do you find the max one? You
Okay, so
Return the maximum value element.
yes.
So we can do one thing like keep a variable, store a minus, like smallest number in that,
Mm-hmm.
and compare it like with the whole our frequency array or like data structure.
Yeah.
If we found greater than that number, like smallest number, keep updating it like while traversing.
Very good. Very good. That's a very good algorithm. That's exactly what, of
And
course, Venkat said the
I
same thing.
think
Yeah. Go ahead.
we need two variables, right? Not one variable. One to store the, one to get the maximum count and one to store the character which is having that count.
Very good. Very good. Because
We
not
need
the
to
maximum. We can store the three, but what is the
the
three? What
character.
is that character? Exactly. Yeah.
Yeah.
So we can store that integer. The what is the integer of that number, and we can
Index.
yeah
Index. Yeah.
yeah, not the index. Yeah, exactly. Sorry, index. Yeah, because we create the 128 character array, right? So That's exactly the algorithm. So basically what we are saying is we can take, this is almost similar to this algorithm which we already had. So here is the algorithm, right? So permutation wise only, it's just like this. Will only have a single string, not two strings, right? We will count all characters, and that while counting, we can maintain two variables. One is maximum. So after you incremented, is this the maximum than the maximum what we already had? If that is the case, you need to store that character, or you need to store what is the value of I, right? And then the maximum as well, you need to update the maximum. I think we can do really quick, I think. Can we implement that? If you guys have a little, like another 5 more minutes, we can implement right away. It is a character permutation problem. So it's just a matter of changing the last method, right? So of course I did not even execute this, but I can execute this method. So what we are discussing here is, so let's take this algorithm. So we can just copy paste and change it. So first one is only one, we need to find max character. This is character, char, I think, characters, or char, and s1. So here is what is that, max occurrence? Yeah, max occurrence, max OCCU or BNC, max occurrence character, right? So first one is uh, is it length? We need to compare length. Yeah, length is greater than 128, right? It won't work. So we can't execute this. Return false, or return something like, or throw an exception, something like that, right? Or you can just print it actually. So you can, instead of saying like, you can say void here, and you can print, right? Console dot write. So you can print.
But Suresh, that S1 dot length gives the string content length, right? Let's say if I have a five characters in it, in that string,
Mm.
so how that 128 will be matched? I mean, comparing? I didn't understand.
So
It's
since
a kind of character ASCII array.
yeah, ASCII array, if you are using more than 128, the string with more than 128 characters, right? So that means
Okay.
um, the length. Let me remember. Uh, yeah, I think you can still use it, right? Yeah, it's not
Okay. Okay.
duplicates. Yeah, so you can have 150 characters, right? But you can use the same character, right? So I think that we don't need this if condition.
Yeah.
Correct me if I'm wrong. Yes, yes.
Yeah. We always the characters ends 128, right? Ends with or starts with ASCII characters. I
Mm,
don't.
mm, mm.
I
Yeah,
asked.
we need to compare that S of I. If the S of I,
Yeah, S of I is greater than 69 or one less than 128. That then we have to consider. Otherwise, we throw an error
yeah, less than
because
0
that is where like all the characters.
or
Right.
greater than 128, that means you use
Eight.
something which is not ASCII character. Yeah, so that's a
Correct.
good point. Console dot write line. So input does not have input does
Invalid input, you can say,
invalid input. Yeah, you can say invalid input.
or invalid character.
Yeah,
I think you can say because we are
invalid
going by
input
character
with
character.
the character with the not with which is that is not ASCII character. A
Yeah, that's right.
C I I. It is not ASCII. So because if you got the number which is greater than or less than 0 or less greater than 128, definitely, or greater than or equal to 128, because the characters start 128, 127 is the last one, 0 to 127, right? So if you use it something like this, let's say this character is 128. See this? So this character is one. These are the characters which is greater than. So our algorithm only works for these characters. So we can check that. So simply, what we are doing here is we will take this integer. Okay, let's. Oh, not here. I need to do here. So we took the integer counts and max count, right? So we also need two more integers, like max integer integer dot min. We need to take integer dot min. I don't know how to take that.
Put it like right now. You can put it -1.
Yeah, that's right. I think that's fine. Yeah. And we also need to take we can take the character directly, so max
Yeah.
spent character. Okay, so now what we are doing is we are incrementing this count. So and we will compare once you increment that, right? So then what we do is we'll compare s1 of I if this is greater than max, right? That means
And
max equal to this one, isn't it?
yeah, update that max. Yeah,
Update. We need
character
to
count.
update the max.
The character count.
This is let's say a occurred three times, so max is three, and at the same time character. What is the character max occurrence character
After
equal to
is
s of
equal to
s of
s
I?
of I.
Yeah.
Yeah.
So let's say a occurred three times. So we are saying maximum so far three times, and what is that? A. That character is a. Okay. So once you're done with this, definitely you will find the maximum here, and you can simply print. Print is also fine, right? And so that right line. You can say I think max. You can also say max character occurred. OCCURRED occurred how many times? Max times. There could be some bugs we need to figure out unless I run this one. So do you think this will work? You can
Yeah, I
see.
hope so. Yeah.
Yeah, you can see that. So okay, so the extra character that has what is this? Oh yeah, this is the function, right? So we can try it out. So here first time I'm like kind of doing
Can
and
you do,
trying out.
can you do trial run? Just like we'll go and just take.
Yeah, we can try. So here is the example, right? Let's say for EAAAB, right?
Yeah.
We can try that. EAAAB. See, so I'm going to run. Don't know if it creates any problems. Compilation failed, huh? Where, in which line? Did I forgot line number 110? 110. Oh, here. Oh, shit. I should put after semicolon problem. Line number 119. Max occur character. Oh, maybe to string. I need to convert that to string. To string because, huh?
A string of you can say
Unassigned. Oh,
you
this one
can
is unassigned. Oh, okay. It says unassigned. So for the time being, just assign like this.
empty character. Yeah.
Just 107. 9:30. Half an hour. Yeah. Yeah. So yeah, I think I have ran out of time. I will finish really quick. 107. What are you saying? Empty character compilation error. Empty character literal. So can't we? put this? I don't know. Let's try empty.
Yeah, give some space. Yeah,
Yeah, let's see. Okay, so see that A occurred three times. We got the answer.
perfect. Yeah,
So let's see
perfect.
how it is. So of course, I will put just the spaces here. So for the given string, A occurred three times. See that, right? So and even you can see all the other things. So here is a unique character count two. This one has a unique character count, and this one has unique characters false. And here are different permutations. Without sort, with sort. So I will send this link so you guys can see line by line and you can execute this. I hope this is helpful. Any questions or any last minute comments, or is it helpful?
Yeah,
Okay,
Yeah.
super
Um,
helpful.
Definitely,
Yes, sir.
Suresh. Yeah.
So,
cool. So we'll
Thank you, Suresh.
no
Thank you so
problem.
much for taking your.
No problem.
Thank you,
I
Suresh.
this yeah. So I will send the link and the video recording as well. We'll discuss few more things from yeah. Go. What is Tarun? What's that?
can you share the what is it? Discord group link?
Yeah, Discord group link. No,
Invite.
just ping me on the Discord. Ping me on the you have Discord,
Okay.
right? There is no group actually. What I do is
Yes.
I will create individual groups here. I don't know how to create more than 10 people. The 10 people group here. So I will add to that. Okay.
Suresh, I sent out. Did you check? You got it or not?
Yeah, I think I
Ma-
got it here.
Okay.
Someone pinged. Oh yeah, is that this one? Lopo? No, it's not the pending. Okay, here. Which one is it? This one? Let me check.
Mm,
I don't know. So I did not. Uh, is it this one? What is the name of the Discord ID? So we'll figure. Yeah, we'll figure that out again. Okay. What is that? Can you repeat?
Srini, I'll help you.
yeah,
I
yeah. Okay,
Yeah,
no
yeah,
problem.
yeah. Venkat can help you on that. Yeah, please ping me
Yeah,
so that I will add to the group. Okay. I just
yeah.
shared.
yeah, sure.
Thank you.
I just shared the link of the algorithm as well in the chat, so you guys can copy if you want to look at the algorithm real quick. Okay.
Yeah, thank you, Suresh.
Cool
Yeah,
then.
thank you. Have a nice
Nice day,
weekend,
everyone,
Suresh.
and
Thank you. You too.
talk to you next week. See you.
Bye.
Thanks,
Yeah,
Suresh.
bye
Thanks,
bye.
everyone. Bye. Bye.
Bye, everyone.